Welcome to Gravitation 9.8 on. Now we will discuss the Kepler planetary motion. Kepler is a scientist who the observed the planet star on the sky, and he made many telescopes. And from the some reference book, we know that Kepler has big interest on the telescope, and more scientists, more books say that the telescope is the second wife of the Kepler. Now, about planet, Kepler gives three law. First law, here he discuss about the um, planet motion and orbital motion. Second, related to the aerial, and third is time. First is here every planet like this. This is the planet, and this is sun. This is sun. Every planet moving around a elliptical path. This is the elliptical path. Every planet moving around the elliptical path focusing the sun. I also repeat, the first law states that every planet moving around the elliptical path focusing the sun. This is sun, and this is planet. Every planet moving around the elliptical path focusing on the sun. This is the first orbital law of Kepler. The second law is here. Second law is here. The planet, if the planet is here, if the planet is here, and this is the elliptical path, and here is the sun, here is the sun, and this is the planet. The planet revolving around the sun. After some days, after 1 day, the planet new position is here, and is swept some amount area, is swept some area, that is shaded line, some area. Okay, 1 day. This is the time 1 day, and here the planet is here, and the new position is here. After 1 day, interval between this and this, 1 day is here. If A1, this is the A1 area, and this is A2 area, Kepler second law state that A1 is equals to A2. Why? The time period is equal. Time period is equal. The Kepler law state that the if equal time period, in equal time period, the area swept the planet is equal. The planet move slowly in the orbit. Planet move slowly or fast in the orbit. It swept out equal time in equal area. This is area is 10 unit. If we consider, for example, just example, this is a elliptical path and this is sun. There is a sun and this is a one planet here, and the new position is here after 2 days. After 2 days, the area is here, shaded line is we consider 20 unit. This is time is 2 days. So 2 days time is 2 days. The area is 20 unit. Okay. And next, the planet is here, and after 3 days, after 3 days, 3 days, the planet is here, new position, this position and this position. The interval of this position is 3 days. So what will be the area of this? 1 day's area equals to 10 and 3 days area equals to 30 unit. So I also repeat, the Kepler third law is second law state that equal time interval, the every planet swept out equal area. Equal time interval, it swept out equal time interval, it swept out equal area. Okay, next, third law. This is the elliptical path, and the elliptical path there are two axes. This is called minor axis. This is defined as minor axis. This is minor axis, and this is major axis. Major axis. Okay. So if we consider this is A and this is A, so major axis equals to 2A, and this is B and this is B, this is B. So minor axis equals to 2B. The Kepler third law state that the time period, the time period is square of time period. That is, square of time period means the planet is here, and the after revolution 1 covering the path, and the covering the path, the time taken is called the time period. Time period means the, if the planet is here A point, after covering this path, when the planet of the same position A, and the time taken by the planet is called the time period. Also repeat, the planet is here, the planet moving around the, this is sun, planet moving around the sun, planet moving around the sun. After moving full complete motion, full complete revolution around the sun, the time taken is called the time period. Time period is defined as T. Let's consider time period is T. Say any planet A. The time period, and this is the axis, major axis A and A. This is the center. Let's consider the time period is here. State that the time period is square of time period is proportional to semi major axis. The major axis is 2A and semi means half. This is AQ. T square proportional to cubic of semi major axis. I also repeat. This is the planet, and this is the sun, and the, sorry, this is the path, and this is the planet A, and this is the length of the semi major axis. Semi major axis. Let's consider A, and the time taken to complete revolution is T. So Kepler third law stated that T square proportional to A cube. T square proportional to A cube. Okay, this is a Kepler third law. Here the what most interesting is the Earth closest to the sun is called the perihelion, and the farthest is here aphelion. The closest path is called the perihelion, and the largest distance between the earth and sun is aphelion. Okay, so the all PDF and link, all PDF given below to the video link. Okay, if interested student, go here.